So this is from 2, structure of the atom and the periodic table. Let us tackle question number 1. That was done in 2001 and it was on paper 1 number 3. The electronic structures for elements represented by letters A, B, C and D are these are the electron configuration of different elements. That is, A has an electron configuration of 2.8.6, B has an electron configuration of 2.8.2, C has an electron configuration of 2.8.1, and D has 2.88. Let's go to the question directly. A, select the element which forms a double charged cation. So maybe for this one should be in a position to define a cation and an ion. So what is a cation? A cation is a positively charged ion, meaning it is an ion that has lost the electron. So that one we refer to as a cation. So, but according to the question, that is Roman 1, a double charged cation, meaning it is the ion that is going to lose 2 electrons. That is the ion that we are saying it is a double charged cation. So from the element that has been given, we need to select an element that loses 2 electrons in order to gain the stability. So that one will be referred to as a double charged cation because it will lose 2 electrons to gain the stability. From the electron that we have, B is a double charged cation because B will lose 2 electrons to gain the stability, that is 2,8. So B is a double charged cation. If you go to Roman 2, a soluble carbonate, if you remember in salt, when we talk the part of solubility, we used to say all carbonates are insoluble except those in group 1. So from the element that has been given, we need to select an element that belongs to group 1 because that is the element that will form a soluble carbonate. So a carbonate that is soluble in water. If we select these elements, you will find C belong to group 1 and C is sodium. So meaning if we have sodium carbonate, it's soluble in water. So B, which element has the shortest atomic radius? So first, if you look at these elements, all of them belong to group period 3, meaning they have 3 energy levels. But if you look at the number of electrons, they have different number of electrons. The number of electrons increases across the period. And you look at A, B, C, and D. The one